Well, good afternoon, everybody. Hope everybody's having a good time so far. Thanks for coming out this afternoon. My name is Donn Morrill. I lead solutions architecture for something called the Alexa Voice Service, which we're going to talk a lot about today. Hope everybody's getting ready for the big replay party tonight. I know this is the last talk before the party, so I thank you for coming. Last year at reInvent, I was asked to give a repeat of my talk at 8 a.m. on the Friday after the replay party, so I feel like I've been promoted or upgraded or something, so thanks for bearing with me while we get through this. I'm going to talk today about how you can integrate Alexa and voice assistants into various products. A lot of you already know that Alexa is built into different types of speakers, but today we're going to talk about some other form factors and kind of spark the imagination in the different types of devices that you might think about putting Alexa into. So let's get started. Way back in 2014, November of 2014, seems like a million years ago now to me, we released the Echo device. And it was the first device that contained Alexa. And you could speak to the device, and you could play music through the device, and ask it to do a few other interesting things. And we realized that at the time, it was a little bit of an experiment. We weren't quite sure how it was going to go, how Alexa was going to be received. But we were very pleasantly surprised to hear that the customer feedback was really good. And so we decided very quickly that we wanted to open up the Alexa and allow developers to come in and then help expand its capabilities. And so our vision became, we want to bring Alexa everywhere that customers find value with Alexa. So our mission was Alexa everywhere and Alexa anywhere that customers wanted her. And at the same time, we also wanted to make Alexa get more intelligent over time, get it smarter. And there's certain things that Amazon can do over time to make Alexa smarter, but we realized that we couldn't do it ourselves. Just like we couldn't put Alexa anywhere by ourselves, we couldn't make her get as smart as we wanted her to be by ourselves. So we released a couple of capabilities, SDKs, APIs, tutorials, things to help spurn kind of an ecosystem or a developer community around Alexa. So we released something called the Alexa Skills Kit. Some of you may have heard of it already. The Alexa Skills Kit, we're going to talk a little bit about it today, but essentially it's a set of SDKs that allow you to build new capabilities into Alexa. We also released something called the Alexa Voice Service, or AVS, which is really the topic of the conversation today. And the Alexa Voice Service allows you to embed Alexa into other consumer electronics devices, not necessarily produced by Amazon. And so we really built this kind of open platform, open set of APIs that allow device makers, consumer electronics makers, hobbyists to come in and integrate Alexa in unique and interesting ways into their products. And so if you fast forward 4 years later up till today, we now see that there are literally hundreds of different types of devices that have Alexa in them, and not just speakers anymore. Of course, there's speakers and sound bars. We have devices from Harman Kardon and Ultimate Ears that have Alexa built into them, but you're also seeing things like smoke detectors and smartphones and alarm clocks and tablets. And so what we're going to do today is talk a little bit about how you can build Alexa into some of those new, interesting form factors. In order to do that, I first want to start talking about how one interacts with Alexa. As you probably know by now, Alexa is a cloud-based service. So I want to talk a little bit about how you interact with Alexa. Then we're going to talk about some of the specific tools and capabilities that Amazon has provided to help you bring Alexa to your devices. And we're going to dive a little bit deeper into the architecture behind the SDK and some of the considerations that you need to think about as you're integrating Alexa into your products. So here's a typical example. We happen to have a picture of a nice Harman Kardon Allure speaker here. It's one of the many connected speakers that have Alexa built into it. They've been a great partner along the way. And so, believe it or not, when we wrote this demo, we didn't know it was going to rain today. But you have this person here wearing a raincoat and a rain hat that says, "Alexa, will I need an umbrella tomorrow?" And so the person is asking the device, will I need an umbrella tomorrow? What's going to happen is that the device is going to capture that audio. We call that an utterance. Take the utterance, and it's only streaming to the cloud once it hears the word Alexa. We're going to go into that a little bit deeper in just a minute. It streams that audio up to the cloud, and then the Alexa takes over from there. So from our perspective, the device is done doing what it needs to do for now. That's just to listen for that wake word Alexa and then capture the audio. The rest of it happens in the cloud on the Amazon side. So the first thing we need to do is we need to take that utterance and we need to turn it into text so that the machine can understand what the person is actually saying. So ASR is the first step in a multi-step process in order to return a result to the user. And so the text comes into, will I need an umbrella tomorrow? Now, turning speech into text is a relatively straightforward exercise today. A long, long time ago, when I first started working in speech recognition, the cutting-edge systems could recognize 5, 10, 20,000 words. Today, cutting-edge speech recognition systems, or ASR, can recognize 10 or 20 million different words. Does that mean we solved the language understanding challenge? Not even close. The hard part really comes in what we call NLU, or natural language understanding. That's taking those spoken words and turning it into something actionable, something that the machine knows how to respond to. Think about how many different ways there are to ask for the weather. I can say, will I need an umbrella tomorrow? Will it rain tomorrow? Will it be sunny tomorrow? What's the temperature tomorrow? At the end of the day, you're still asking the same thing, and the machine needs to know how to react to that one thing. And so we pass the ASR through something called the natural language understanding engine, and it turns it into what we see there, a domain. It says, aha, this is probably a weather question. So now I've constrained the question to a certain domain, and I can I'm trying to understand a little bit more about what the user is trying to ask me for. They're asking me, is it going to rain? And there's also happens to be a parameter associated with that. I specifically said tomorrow. If I said, will it rain? Alexa's going to assume it's today. But when I said tomorrow, that's what we call a slot value. And so Alexa recognized there's a slot value associated with it. So now I know what the user is asking for. The next step to do is to pass it off what we call a skill. And as I said before, a skill is simply something that Alexa knows how to do. Fundamentally, there's two types of skills. There's intrinsic skills, which are things that Amazon has built into Alexa. Alexa knows how to tell a joke. Alexa knows how to tell what time it is. But there's thousands and thousands of things that Amazon didn't teach Alexa how to do. For example, how to order a pizza, how to order an Uber, how to check your credit card balance on American Express or Capital One. So as I said in the opening remarks, we developed something called the Alexa Skills Kit, which allows third-party developers to come in and build new capabilities for Alexa and advertise those capabilities to users through something called the Skills Store. It's very similar to an app store on a mobile phone. And so you can activate these skills if you want, for example, to ask Alexa to order a Starbucks for you. And so in this case, Alexa had determined that the skill that it needed to invoke was a weather skill. And so she passes off all that information, the request for the weather and the slot value of tomorrow to the weather skill. And now the weather skill is essentially the business logic and knows how to respond to that request. And so the last step is to really take the response. The weather skill is going to spit back some text that says no rain is expected in Las Vegas tomorrow, which as of yesterday would have been a lie, but hopefully it's true today. And we turn it into speech now. We convert it from text to speech, and then we send the response back down to the device, and the device simply plays the audio back out to the user, and the interaction is done. Again, the processing on the device is relatively lightweight compared to all of the heavy lifting on the NLU side that Amazon takes care of in the cloud for you. Not only do we have the ability to talk directly to the devices and have the audio going back and forth up, we also have another class of devices called Works with Alexa devices. These are essentially all the smart home devices that can be controlled by Alexa. We're going to talk a little bit more about kind of the smart home model and the difference between Alexa built in and Works with Alexa a little bit later on in the talk. But in this case, just really quick, when I say, Alexa, turn on the living room lights, it goes through a similar set of orchestration steps, ASR, NLU, but in this case, there's a specialized skill called a smart home skill. And so Alexa recognizes that this is a smart home skill and that you have a Philips light bulb somewhere in your Alexa profile, and so it hands off the request to the Philips Hue skill, and from there, there's another set of data transfers and paths that happen in order to make not only the device say, okay, turning on the light, but also to actually turn on the light. And so when you put that all together, today we have a developer system and an ecosystem that is growing very quickly. Alexa is supported today in 14 countries. There's over 100 devices today that have non-Amazon produced devices that have Alexa built into them. There's over 5,000 smart home products that work with Alexa. Today there's over 50,000 skills available in the skill store, and there's hundreds of thousands of developers that have registered at developer.amazon.com to work either with Alexa skills or to work with the Alexa voice service. And so what that means for you as a device maker, if you're bringing Alexa into your device or bringing Alexa to your customer, Alexa is going to continue to get smarter over time without you necessarily having to do anything. As new music providers are onboarded to Alexa, as new smart home providers are brought into Alexa, as developers develop new skills, those capabilities automatically become available to your customers and users of your device because, again, all of that happens in the cloud, and the device is simply responsible for sending the audio back and sending the audio up and receiving the responses back. So that's a really great benefit to bringing Alexa into your device. So let's go into a little bit more detail now on how you actually go about putting Alexa into your device. If you wanted to take the simple approach, and we've actually had some people do this, you could just build a plastic mount, screw it on the ceiling, and stick a dot into it. But that's not what we're here to talk about today. We're here to talk about you as device makers, as hardware manufacturers, actually building Alexa into your custom product. And so the first step, as we spoke about in the opening example, that you need to do when you're interacting with Alexa, of course, is collect some audio. You need to listen to the audio from the user. And in some of the early studies that we've done with Alexa and some of the work that we've done with our AVS partners, we found that far-field audio, the ability to detect the user from across the room, is really the magical experience that users are looking for. That's opposed to, say, a push-to-talk model where I might have to push a button on a device, or I might have to phone my phone right up to my face in order to interact with an agent. Being able to speak to my Echo or my third-party Alexa product from across the room is really where the magical experience happens. But it brings a lot of challenges with it, right? The farther you are from the device, the more possibility there is for ambient noise, the lower the audio signal from the speaker is going to be. And so there's some things that you need to think about. The first thing you want to think about is the audio front end. And so you've got a set of hardware, a set of microphones, you have a DSP with various audio algorithms that are running on it to help clean up that signal and get the best, cleanest signal up to the cloud so that Alexa has the best shot at doing ASR and NLU against that utterance. And so if your expertise lies in audio hardware, audio processing, signal processing, you might decide to build your own audio front end. But we've worked together with some of the well-known names in the industry to make hardware reference solutions available to you in various form factors with various DSPs and various SoCs. So if you want to work with NXP or XMOS or Intel or any of the other great names up there, they have development kits that are already validated to work with Alexa, and they can give you a really good head start when you're thinking about embedding Alexa. It's also going to depend on the use case of the device, right? If you know the form factor of an Echo device, it's meant to sit in the middle of the room, so it's got a circular microphone array on top of it. But there's other devices that are mounted up more like a tablet or against a wall like a television. In those cases, maybe a linear mic array might be a better solution for you. So we have lots of different development kits to choose from. If you go to alexa.design/devkits, you can learn a lot more about those development kits to help get you started. And then so once you have the hardware, the microphones and the DSPs, there's several onboard components that you need to think about. The first one is the wake word engine. And the wake word engine is the thing that's always listening locally on the device for that wake word Alexa. It's the things that wakes up the device and starts streaming the audio to the cloud. A lot of people ask me, is Alexa always listening? And the real answer is sort of, right? The device itself is listening for that wake word Alexa, but nothing is going up to the cloud until Alexa hears that trigger word. In addition, once you start streaming up to the cloud, we actually take a second pass at the wake word. So we listen for that wake word again. It's called cloud-based wake word validation, so that we can apply a lot more processing horsepower in the cloud and really understand if the user said the word Alexa or if maybe it was just a false wake up, right? And so we take that second pass to help build that customer trust, and we'll actually shut the connection down. We'll tell the device to shut the connection down if in turn the user didn't really say Alexa. Maybe they said, my sister got a Lexus for her birthday, and the cloud was smart enough to figure it out, but the onboard wake word engine wasn't. The second thing that we have on the device is the SDK. We're going to talk a lot about the SDK that Amazon has developed to make it easy. It abstracts away a lot of the lower level APIs and the JSON parsing and all of the complexity that comes with interacting with Alexa. And then the third one, of course, is that you need a connection to the cloud, right? In order to talk to Alexa, it's a cloud-based service. You need to have a device that either has Wi-Fi or Ethernet directly or LTE in it. And we're going to talk a little bit more about connectivity in just a few slides. And so once you have all those pieces together, you can actually start communicating with Alexa in the cloud. There's two main constructs that we use to talk to Alexa. The first one is called an event. So an event is something that happens on the device. And so when I say Alexa and the device wakes up, that's an event that gets sent up to Alexa, that gets sent up to Alexa in the cloud that says, hey, something happened on the device that might be of interest to you. And then Alexa's going to process that event, and then it's going to send back down usually a series of directives back down to the device. And a directive is simply, as it sounds, telling the device to do something. So if I say, Alexa, what time is it? That's a speech event that gets sent up to the cloud. And then what's going to happen is a response is going to come back down that says, I think they said what time is it? Here, read them out this MP3 that says it's 2:47 p.m. And so under the hood, this is what an event and a directive look like. I know it's a little bit kind of small font there, so I put some red arrows next to kind of the interesting parts of the payloads. The event going up, in this case, is what we call a recognize event. It's probably the most common event. It's asking the cloud to recognize the speech that I just heard on the device. You can see at the bottom there's something called a profile. If the device is meant to be used at a close range, we have what's called a close talk profile. It applies a different audio algorithm to it in the cloud than if it was, say, talking to it from across the room. And then once Alexa processes that event, the directive is going to come back down. And in this case, we see what we call a speak event. And the speak event, again, is probably one of the most common directives that's going to come back down to your device. And generally, a speak directive will contain an MP3 version of the text-to-speech response that Alexa would like the device to play back out to the user. So all that's really complicated, right? We have you can write to the raw APIs if you so choose. You can parse all that JSON yourself. But what Amazon has done is published a C++-based SDK that abstracts a lot of that away from you. So let's dive in and look at some of the model and the architectures of the SDK. The first thing that happens is, obviously, as we said, if I say, how's traffic to the airport right now? Actually, nothing's going to happen because I didn't say the word Alexa before it. It first has to get passed to the wake word engine. So as I said before, the device is listening locally. There's a little 10 or 15 second ring buffer that's always passing all that ring buffer through the wake word engine. When it hears the word Alexa, then it wakes up and the magic's going to happen. Otherwise, it's just going to throw away all that audio and nothing gets saved at all. Once I've detected the wake word, then I can start doing something interesting with that audio. The first thing I'm going to do is I'm going to let the cloud know that an event has happened. And again, in this case, I'm going to pass it the speech recognize event. And we use something called the Alexa Communication Library, or ACL, in order to do that. Alexa actually communicates with the cloud over HTTP2. So those of you familiar with HTTP2, as it sounds, it's a newer version of HTTP2 that HTTP that supports multiple simultaneous always-on channels. And what we need multiple channels to the cloud, but we also need an always-on connection so that we can receive asynchronous events from the cloud back down to the device. So for example, if I'm playing Metallica at volume 11 on my device and I need to pause it, but maybe it's too loud for the device to wake up, I can pull out my phone and I can actually hit the stop button on the Alexa app in my phone, and it'll asynchronously send a stop command back down to the device so that I can shut the device up in that case. That's why we use HTTP2, and the Alexa Communication Library manages that connection for me. So then we're going to get the directive back down for the device, and it gets handed off to something called the Alexa Directive Sequencer Library. Why do we have a library just to process the directive? In reality, we spoke about having the speak directive as being the most common one. In reality, there's a whole bunch of stuff that can be happening on Alexa at the same time. Alexa in the cloud is a really big state machine, and the cloud has to understand everything that's going on the device so that it can interact and give the right response to the user. From there, it gets handed off to what we call capabilities agent. And a capability agent is simply an abstraction of something my device knows how to do. My device hopefully knows how to speak audio back out to the user. It probably knows how to stream music as well from a streaming URL. It knows how to trigger an alarm. Maybe it has a camera. Maybe it has some other type of sensor or capability that Alexa knows how to control. And so the capabilities agents are the abstractions of the thing that the device knows how to do. And then we have the final component, which is the Alexa Focus Manager. And the Focus Manager tells Alexa, as it sounds, what should be in the foreground. What do I want you to do next if there's multiple things happening at the same time? For example, again, let's say I'm going to watch a game and I want to play some music before the game starts. So I ask Alexa to play Metallica at volume 5. I throw a pizza in the oven and I say, Alexa, set a timer for 20 minutes. Well, when that timer fires, I want the audio of the timer to take a higher order than I want it to stop playing Metallica and play the timer back to me, not wait till my song or my track or my playlist finishes before playing the timer. Otherwise, I'd have a burnt pizza. And so it's the Focus Manager that tells the device which of the things should take priority over the other. And even if I'm playing a timer and I say, Alexa, stop, I want to stop the timer, maybe I want to stop the music, the user speaking to the device should take precedence even over playing the music and even over the firing of the timer. And so that's a very simple example. There's even more complexity that can happen on the device. So it's important that the Alexa Focus Manager library be there to help us understand what the priority of all these events are. And so after all that happens, in this case, back to the beginning of the example, we're saying, how's the traffic to the airport? Eventually, we get that text-to-speech response. We get the speak response. And then that gets handed off to a media player. Most of the time, the media player is going to be provided by you, the device maker, and the media player needs to play that MP3 file back to the user. Maybe it needs to play some ringtone because the alarm went off, or maybe it has to stream a URL from the cloud if somebody has to play some music from Spotify or iHeartRadio, for example. And so that's the Device SDK. Again, you can do that all yourself if you want to, but the SDK is freely available on GitHub, so it's a great way to get started. Between the Device SDK on GitHub and the development kits that we've spoken about, it can help accelerate bringing Alexa to your product. If you want to take it even to the next level, we have a series of solutions partners, solution providers that can help you accelerate even quicker. There's some systems integrators out there that have gone through the heavy lifting of integrating Alexa into various application chips. So let's say you're developing a speaker, for example, and you need some help not only with the Alexa stack, but with the audio stack as well and with the playback stack. There's systems integrators out there such as LinkPlay and Sugar and DTS who have done most of that for you. So you can actually start with their modules, their connected speaker module, and it can really help accelerate getting a device to market quicker. And then perhaps the quickest way to get a device to market is through what we call an original design manufacturer, an ODM. And an ODM essentially creates white-labeled versions of consumer electronics products for you. So if your company's skills lie more in distribution and in marketing, you can actually work with an ODM to take one of their prefabricated Alexa-enabled devices, slap your logo on it, and start selling it on Amazon.com. It's a very quick way to get started selling Alexa-enabled products. So that's kind of the core Alexa software development kit and the tools and the capabilities that you have. What I want to do now is talk about a couple of different form factors that are interesting to us and hopefully you'll find interesting to you. Let's start with headphones. Headphones is a fairly new space for us, but it's been obviously one that the customers have been asking for a while. Earlier this year, we released something called the Alexa Mobile Accessories Kit. And so what this does is it moves a lot of the AVS client functionality from the device itself into a mobile phone. If you think about a set of headphones, they don't necessarily have a lot of processing power. Maybe they don't have enough capability on them to detect a wake word or to run the full SDK. And so what we've done is we moved the client to the mobile phone. And so if you've got a device, either a headphone or maybe a Bluetooth-only speaker that you want to use with Alexa, you can communicate over Bluetooth back to the phone and interact with Alexa through the headphones or through the Bluetooth speaker that way. So in essence, the phone becomes the connection to the cloud, and it becomes all the client logic moves to the phone. So that offloads a lot of things, right? You don't necessarily need enough processing power on the headphones or on the speaker in order to run the full Alexa client and some of the other capabilities that come along with Alexa. It offloads the connectivity to the cloud to the phone, but it also still provides a lot of the feature-rich capabilities that Alexa would have on a device when you integrate it natively. You can do things like Alexa calling. You can do location-specific information, a lot of the things that you can do with a device with Alexa built into it proper. A couple of considerations when you're thinking about embedding Alexa into mobile devices. A lot of the devices that you're familiar with that have Alexa in it, like an Echo or like a Show, have kind of a visual indication of what's going on the device. On the Echo, they've got the blue light ring. The Show has kind of a blue chrome going across the bottom. But in the case of a headphone, obviously, generally you're not going to have some visual indication of what's going on. So it's important that you still maintain the customer trust, and so the customer knows what's going on with Alexa. We want the user to know when the device is listening, when it's streaming to the cloud, or maybe when it's turned off. So instead of maybe using visual cues, maybe with a headphone you might want to use an audio cue, or what we call an ear con. So if I tap the device in order to wake up Alexa, maybe there's a little bing or something that lets the user know that Alexa is now listening. And then once Alexa is done listening, maybe there's a different ear con that says, OK, I'm done. I'm going to now send the audio to Alexa and send the response back down. So those are things just to be aware of as you're integrating Alexa into a device that might not have a visual presence in front of the user. The second category that I want to talk about is smart screens. This is a new space for us, but it's a really interesting space. Alexa is a voice-first service, and Echo was a voice-first product. But I like to tell a lot of the customers and the device makers that I work with, don't integrate Alexa or voice into your product just because it's a cool new technology, right? Do it because it's the right experience for your users, and it's going to make your customers more happy. It's going to be a more magical experience. It's going to remove the friction, if you're a speaker maker, of asking the device to play some music. But in a lot of cases, a visual interactive element is going to make it for an even more delightful experience. And so we want to encourage people, when you're able to have a visual element to your device, that you think about doing that as well. We've released some new capabilities that can help with that. But for example, if I'm enumerating over a list or a calendar, it's really hard if I've got 15 things on my shopping list to go, Alexa, what's on my shopping list, and just wait and have her read off all those 15 things. And so in that case, incorporating a visual element, so instead of saying, read my shopping list, I can say, Alexa, show me my shopping list, and then I can scroll up and down on it and see the items. It really enhances a lot of the capabilities of Alexa in a delightful way. And so back in September, we released a couple of capabilities that help bring visual experiences to Alexa-enabled devices. If you think about a visual experience with Alexa, there's kind of two sides to the equation, right? First off, the skill has to be able to produce the graphics that get displayed on the screen. So we released something called the Alexa presentation language. And so if I, for example, am building a horoscope skill, a skill that tells me my horoscope, in addition to sending the audio back to the user, or the text that gets converted to speech, maybe I want to also send back an image of the character of whichever. I lost the word. I want to send back my horoscope sign in addition to just the kind of the spoken language. And so the APL, or Alexa presentation language, allows skilled developers to send back those graphical images. This is what an APL looks like. It's formatted for different form factors, different screen sizes. It's a JSON format. It looks a lot like style sheets, for those of you that are familiar with style sheets. And you can see right there on the right, the three red arrows are pointing to interesting parts of it. Kind of what image should I use for a small screen, what image should I use for a medium screen, or what image should I use for a large screen. And so that's kind of the skill side of building an interactive experience that has both voice and visuals. We also have some device-side tools for you as well. We recently released something called the Alexa Smart Screen and TV Device SDK. It rolls off the tongue, I know. I just call it the Smart Screen SDK. That's available. So if you're building a screen-based device, this, in addition to having kind of the core Alexa functionality, will also take that the APL, the presentation language, and convert it into HTML for you so that you can easily display it on the screen. And just like we've done with some of the audio front ends, we've released a reference hardware kit that allows you to get started very quickly in building smart screens. I happen to have one of them here with me today. This is the Smart Screen Development Kit. It's got microphones on the top and a little screen and a speaker and some other capabilities on it. You're happy to come and take a look at it afterwards, but this can really accelerate your development if you want to think about building Alexa into a device with a screen. The next thing is speakers. I know we talk about speakers, like everybody's got a speaker already with Alexa in it, but there's some interesting things to think about and some considerations when building a connected speaker that are applicable to any type of device. So I want to talk about that for a second. The first one is that is built to play music really loudly, right? And if it's playing music really loudly, it makes it much more difficult to hear the word Alexa and wake up, and it also introduces a lot of noise into the channel when I'm sending the audio up to the cloud. It makes it harder for Alexa to understand what's going on. So we've come up with a couple of tricks that help us hear the word Alexa even if music is playing out of the speaker. The first one is called acoustic echo cancellation. And what that does is that when Alexa is running locally on the device, we can actually take a source signal from the device before the audio hits the signal, and we can subtract that out from the sound coming into the microphone. So if I get Metallica playing out of the device and I say, Alexa, what time is it at the same time? The DSP can subtract out the Metallica because it has the source signal for it as the audio is coming back in through the microphones. It can focus in on the speaker and less on the audio that's being played by the device. That's what we call acoustic echo cancellation. The second one is an interesting one called beamforming. For those of you familiar with the Echo and have paid attention to what the light ring does when it wakes up, the light ring turns blue, but part of the light ring also turns white and seems to mysteriously follow you around the room. If you actually walk around the room while you're talking to your Echo device, the white ring will point at you. It's kind of spooky the first time you see it, but once you understand it, it's kind of cool why we do it. It's got a circular microarray on it, 7 different microphones. And so what happens when I speak to the device and I say, Alexa, the sound is moving relatively slowly in computer terms over the kind of the plane of the microphone array. And so what we can do is we can look at the first microphone to detect that sound, and we can look at the last microphone to detect that sound. We can jack up the gain on those microphones, and we can actually turn off the other microphones that aren't in the direct path of the user. And so we're actually able to essentially focus in the microphone array on the user, focus in on their sound, and cut out any ambient noise that might be going on in the room. And that's another trick that helps us get a cleaner signal. Multi-room music is another capability that we recently released. This is something that a lot of people have been asking for. It's the ability to synchronize audio playback on a set of heterogeneous devices. So this works on Echo devices today. If you've got 3 or 4 Echo family devices around your house and you say play Metallica everywhere, you're going to hear synchronized audio on all those devices. We've opened up that technology to third parties. So now if you're building a connected speaker, you can implement our multi-room music technology. We have a reference implementation from our friends at NXP, for example. And so if you've got a speaker and you have an Echo and I say play Metallica in the living room, the MRM technology will actually synchronize the playback of the audio on multiple of those Alexa-enabled devices. It's pretty cool technology. The next device I want to talk about is Alexa for televisions, obviously very closely related to smart screens, but there's some different use cases there. As you're watching television, there's a couple of things that you expect Alexa to be able to do on your television. Things like powering it on or off, changing the channel, tune to CNN, change the volume, change the input to HDMI 2. So in order to enhance the television viewing experience, we released something called the Video Skills Kit. And as it sounds, that's a skill that a television maker or maybe a cable company would implement that allows Alexa to control the capabilities of a set-top box or of a television. And there's a couple of systems integrators out there, companies you might have heard of, like Aris, Cisco, Discvision, Technicolor, companies that make set-top boxes that have these reference implementations already available if you're interested in building Alexa into a television or, say, a set-top box. The next category I want to talk about is smart home devices. And this is an interesting category. It's a very broad category. It includes not only the speakers that we've talked about, but things like smoke detectors or thermostats or door locks or even robots. I consider roughly a robot to be part of the smart home. It's a cloud-connected device in my home. Today, as I said earlier on, there's over 5,000 different smart home devices today that can be controlled by Alexa. Things like GE, Sony, Lutron, smart things from Samsung, Wemo, Honeywell, and many others. So when I say, Alexa, turn on the lights, those devices know how to react to that, and Alexa can control those devices. This is a quick architectural diagram of how a smart home device might work with Alexa. As you can see on my right, you have in the blue is the Alexa cloud, and on the left is what we call the device cloud. This is a a cloud that the device maker uses to control that system, right? To turn the light on or to turn the light off. Here's a sample architecture, of course, on AWS. Hopefully, if you're building a smart home device, you'll consider using AWS for it. But there's a couple of things to consider. Alexa needs to know the state of the devices. Just like Alexa needs to know what's going on the device and in the cloud, Alexa needs to know the state of all of the smart home devices, so that if I go, Alexa, is my front door locked, and I've changed the lock configuration with my mobile phone, or I've actually gone up and locked the door, we need to send those events back to Alexa. So you can see the blue line down there, the directives and the green state updates are going back to the cloud every time the state of the device changes, so that when I say, Alexa, lock the door, she can say either the door is already locked, or when I ask to query the temperature, she knows what the temperature of the thermostat is. And so what we have is a works with Alexa example here. This is the Ecobee 3 thermostat that came out a couple years ago. This is a works with Alexa example. So I can control my Ecobee thermostat, but it doesn't have microphones built into it, and it doesn't have Alexa built into it. So I still need another Alexa-enabled device in my house in order to do it. So when I say, Alexa, set the temperature to 72 degrees, the audio comes into the Echo device, in this case, goes up to the Alexa cloud, but from there, then it has to go out to the Ecobee skill, down to the Alexa cloud, and finally down to the device to set the temperature to 72 degrees. But last year, Ecobee came out with the Ecobee 4 thermostat, which has Alexa built in. We work with them, and they've got a microphone array in it now. They've got a speaker in it. So I don't need that Amazon Echo or that other Alexa-enabled device in my house anymore. I can speak directly to my thermostat and say, Alexa, set the temperature to 72 degrees, and the device can react locally. But as I spoke about earlier, Ecobee also gets the benefit of having everything that Alexa can do now built into that device. So that device can tell you what the weather is outside. It can tell a joke. It can tell you how much money you lost in crypto last week if you want to ask it what the price of Bitcoin is. So those are the 5 different device classes I wanted to talk about today. I want to just leave you with kind of a few closing thoughts, other things to think about as you're thinking about building Alexa into your products. Perhaps the most important thing, if you walk away with one thing today, it's make sure you maintain that customer trust. Everybody's heard horror stories about IoT devices and smart devices getting hacked and people building botnets from them. And so we want to make sure that we're continuing that customer trust. Customers trust Alexa, they trust Amazon, and so we want to make sure that we continue that trust. And so we published a set of security guidelines, things like using TLS 1.2, making sure you have an OTA capability, making sure that you're planning proactively for security incidences. So if you're thinking about building Alexa into your device, make sure you visit alexa.design/security and think really hard about the security of the device. There's a lot of trust that has to go into a user speaking to that device and having it available in their home. The second important thing here is to test your product, right? We have a set of functional guidelines, a set of UX guidelines, a set of security guidelines that we publish to help you understand how you want to test the device and make sure you've got a delightful user experience. One of the things that we learned early on when we were developing Alexa is that there's this magical tipping point between a really, really bad experience and a magical experience. As we were developing, I remember talking to people that were in the beta program before the Echo was even launched, and it was a horrible experience. It didn't understand anything I said, and it would react in weird ways, and people just didn't want to use it. But then as Alexa got smarter over time and we tuned our NLU engine, there was this magical tipping point, and I'm making up a number here. It's a very small number. When Alexa goes from, say, 80% recognition accuracy to 85% recognition accuracy, it goes from a really bad experience to a magical experience almost instantly. And so testing is really important to make sure that you're doing a delightful user experience. For those of you that haven't seen it, there's a really funny video on YouTube about 2 Scottish guys stuck in a voice-activated elevator that shows you what can go wrong when you don't test your speech recognition system. So if you have time, I encourage you to check it out. I didn't have time to show it today, but it's a really funny video. And finally, once you're ready, you've integrated Alexa into your device, you've gone through the security requirements, you've tested your product, you've sent it to us for additional validation, you're ready to market and launch your product. So once you go through all that process, you're then eligible for the Alexa built-in badge on your packaging, which also allows you to kind of showcase your product on Amazon. In addition to operating a cloud and running Alexa, we also happen to sell a lot of stuff on Amazon. And so if you have that Alexa built-in badge on your device, there's some benefit that you can gain by marketing and displaying your device on Amazon.com. And so if you want to get started, there's a couple things that you can do. I encourage you to visit alexa.design/AVS tutorials. There's a GitHub project that can allow you to run Alexa on a Raspberry Pi in just a couple hours. So please, get started. Everything is open and freely available to you. You can jump in and start using it and start playing with it and really come up with some creative design. I'm always encouraged when I see new and fascinating ways of using Alexa. There was a gentleman that had put Alexa into a Billy the Big Mouth Bass fish a couple years ago. And so we actually took a cue from that, and just yesterday, I think it was, Amazon worked with that developer, and we released a talking big mouth bass trophy that you can talk to Alexa through your fish. I also saw somebody build Alexa into a mock-up of a HAL 9000 computer, which I thought was both spooky and kind of cool at the same time. So I encourage you all to get creative, play with Alexa. The tools are out there. Raspberry Pis are readily available. And think about the different ways that you might want to build Alexa into your products. And that's it. Please take the time to fill out the survey at the end, and hopefully everybody has a good replay party tonight, and we can all stay dry. Thank you.